Hi, my name is Jeroen and I'm here today to talk about organ transplantation and individual treatment effects. Organ transplantation is a hard problem. Given the goal of assigning an available organ to a patient on the waitlist, we wish to maximize the total population life years. This sounds very straightforward, however, it's not. So why is this such a hard problem? First of all, organs are unique and high dimensional. We only see the same organ once, in contrast to other ITE settings where we, for instance, want to assign chemotherapy or radiotherapy to a cancer patient. There is plenty of chemotherapy, but this is not the case for organs. Choosing a patient on the waitlist also means not choosing other patients on the waitlist. Some patients are sicker than other patients, so we have to define a good way of prioritizing patients on the waitlist. And there's a long-term effect for every patient involved, not only those that receive the organ, but the patients that remain on the waitlist. So we can take many perspectives to optimality in an organ transplantation setting. First of all, we can take a population's perspective, saying that optimality is more net life years gained throughout the organ transplantation process. We could also take an individual patient's perspective, saying that whenever we receive an organ, we wanted to maximize our life years individually. There are other perspectives like what does it cost to transplant an organ? We want to minimize organ waste. We want to maximize the ease of surgery, etc. However, each perspective implies some sort of compromise. From the population's perspective, perhaps the available organ should go to someone who needs it most rather than the best match. This is of course in contrast for the patient, whereby we want to receive the best organ that is optimal for me. Given that definition, in many ways, individual treatment effects in organ transplantation is standard. So the data is biased due to previous allocation, as we have allocated organs to patients in the past. The problem is easily written in terms of potential outcomes. We have a Y of O. There's a clear treatment, being the organ. There's a clear outcome, being the life years gained. And there's an individual, being the patient. However, in many other ways, it is not standard at all. First of all, the treatment, being the organ, is high dimensional and unique. So this would be a first. We only see an organ once. Organs are not pills. We have some of them, but they're scarce. The bias is also non-standard, as the patients to give an organ to is limited in the waitlist. So while there are many possible patients, we only can assign the treatment to, let's say, 500 on the waitlist. And ideally, there is no control group because receiving no organ implies death. We already know what would happen to a patient when they don't receive a transplant, otherwise they wouldn't have joined the waitlist. So how should we go about incorporating the ITE estimate into organ allocation? Well, first of all, ITE in organ allocation is very important because the data is super biased by multiple sources. Some sources are the past assignment policies, which we've discussed previously, but also the clinicians themselves by accepting or rejecting offers of the assignment policies, and by the availability of organs and patients. So the patients are constantly changing because the waitlist is, and the organs are unique, so we only see an organ once. We argue that you should combine three different components. First is the ITE estimate to have unbiased or balanced estimates. The second is the match, that is how well an available organ would match patients on the waitlist. And the third is rarity. We do this by considering the patient features, which here range from purple to blue to orange, but also the months that are left for the patient without an organ. In this case, the first patient would have 4 months left, and the available organ and what it would have on potential outcomes given these patients on the waitlist. So for the first patient who had 4 months left to live, we would say the available organ has an additional 6. This is because the features of the organ best match the features of the patient, both being purple. So the future organs in this setting are unknown. This is an additional source of the transplant system that OrganITE should consider. On the left, we see the incremental survival and best match policies would pick the first patient on the waitlist given the available organ. Sickest person first would pick the green patient because they have only 1 month left to live, while OrganITE would pick the blue patient at the bottom. This is because OrganITE combines the months left to live without an organ, that's very low, it's 2. The gain is 4, which is considerably well, and they need a fairly rare organ because blue is only captured once in the figure on the right. We estimate this density. So we've tested this on given multiple different allocation policies. The first one is FIFO, which is a very naive first in, first out method of allocating organs. The second is sickest person first, which, as the name suggests, we pick only the sickest person on the waitlist. Then there's best match. This is a policy that allocates the organ to the patient that is estimated to have the highest potential outcome. A similar policy to this is currently in use in the United States. And incremental survival, which is the difference between receiving no organ and an organ. So basically the ITE, which is currently in use in the UK. And then confident match, which is a prediction method. So confident match is a variant of best match, but given different prediction methods. And then OrganITE. We have tested this on synthetic and real data. Both come with certain caveats, synthetic being that it is synthetic, and real data because we don't have access to counterfactuals in the real data, so we use different potential outcome models to estimate the counterfactuals. Given these simulations, we see that OrganITE has the best performance, and we attribute this to all 3 factors that OrganITE takes into consideration. I would like to thank you to have a look at organ transplantation in individual treatment effects estimation. It is a fantastic problem, and if you're interested, I highly recommend reading our paper on the subject. Thank you very much.